This is page 2 of the conic sections review. We need to sketch and find the important features of this conic section. Now, to do that, first we've got to complete the square and get it into a form that's much more useful. But before we even do that, I want to take a note that this is going to be an ellipse. I know that because we have an x squared and a y squared term. I know since we have two squareds, it can't be a parabola. Since they're added, the x squared and the y squared terms are all added together, it can't be a hyperbola. And since the coefficient on the x term and the coefficient on the y term are different, it's going to have a different x radius and a y radius, making it not a circle but an ellipse. So let's get started. First thing I'm going to do is I'm going to clump together all of the x stuff, so 9x squared and 54x. And I'm going to clump together all of the y stuff, 4y squared and negative 8y. And I'll bring that 49 to the other side. Up next, I'm going to factor, take a 9 out of the x's. So I have x squared plus 6x. And I'm going to take a 4 out of the y's, y squared minus 2y. And I'm leaving space because I'm going to have to complete the square and add some other stuff in. In this case, I'm going to need 6 divided by 2 is 3, squared is a 9. So I'm adding a 9 over here, but I'm not really adding 9, I'm adding 9 times 9. So I'll put the plus 81 over on that side. On this one, it's negative 2y, so what I'm going to need to complete the square is a plus 1, but it's not just plus 1, it's plus 4 times 1, so plus 4. From here, I've got 9 times x plus 3 squared plus 4 times y minus 1 squared equals negative 49 negative 49 plus 81 plus 4 is 36. The last thing I need to do is divide both sides by 36 so that I have, well, 9 over 36 leaves a 4 in the denominator, x plus 3 squared over 4, y minus 1 squared over, and 4 out of 36 leaves a 9 in the denominator, equals 1. Now it's in a form that's nice. So for example, the center of this is going to be at negative 3, comma 1. I know that since it's x plus 3, that means shift 3 to the left, y minus 1, shift up 1. The major axis, that's the axis on the y term, since that's the bigger number, is going to be 3 in either direction. Since this is a 9 in the denominator, it means that the radius is going to be up 3 at negative 3 comma 4 and down 3 at negative 3 comma negative 2. In the x direction, I'm going to go over 2, negative 5 comma 1 and negative 1 comma 1. So here is my ellipse. Now you're going to have to write down the points. I'm not going to, in an effort to save time, but you can see them right there. This is why I like to graph my ellipse, so I can actually just see where the points are. The last thing we need is the foci. The foci are going to be somewhere around here and here. I don't know where exactly, but I know that the foci pull it from being a circle to an ellipse, and they sort of wrap around those foci. So I'm going to figure it out by saying, well, it's the semi-major radius, 3 squared, minus the semi-minor radius, 2 squared, equals the distance to the focus squared. 3 squared is 9, minus 2 squared is 4, 9 minus 4 is 5, equals p squared. So p equals the square root of 5, which is a little bit more than 2. So my point's a little bit off, but if I want to say exactly where they are, I would say, well, it's at -3, comma, and it's up 1, but plus or minus the square root of 5. Let's take a look at the next conic section. Looking at this, I can tell that what we're dealing with is a hyperbola. Again, we have 2 squared terms, the x squared and the y squared. But the difference now is that they are subtracted. So to start off, doing the exact same thing, clumping the x's and y's, we've got 50y squared plus 200y minus 18x squared plus 108x equals 412. Factoring a 50 from the y's, we have 50 times y squared plus 4y with some space. Factoring a -18 from the x's, x squared minus 108 over 18 is 6. It's a minus since I factored out a negative number. And I'll leave some space. Equals 412. The number I need with the y is going to be a 4, since 4 over 2 squared is 4. But it's not really 4, it's really 200. So I will add a 200 over here, being 4 times 50. The number I need for the x's is going to be, well, -6 over 2 squared is 9, which isn't really a 9, but a 9 times -18, or -162. From here, my equation is 50 times y plus 2 squared minus 18 times x minus 3 squared equals 412 plus 200 minus 162, or 450. Dividing everything by 450 leaves me y minus plus 2 out of, let's see, 50 goes into 450. I've got a 9 left over in the denominator. Minus 18 goes into 450. 450 over 18 gives me a 25 in the denominator. This equals 1. This is my equation of the hyperbola. And you can see again, since I have a minus here, it is this hyperbola. Now it's the same exact thing. In the x direction, I go over 3. In the y direction, I go down 2. So I've got the point 3, comma, -2. That's the center. The radius, well, I can tell that this is going to open up vertically because the y is positive. And that should be squared, by the way. Since the y term is positive, it's going to pull it in the y direction. So my hyperbola will go up and down. So let's think of how far up the vertex is. Well, this 9 is the distance squared, so I will go up 3 and down 3. The center is at 3 comma negative 2. The vertices are at 3 comma 1 and 3 comma negative 5. Now, if this was an ellipse, I would go over 5 in the x direction in each way. But this isn't ellipse. Nonetheless, it still helps to plot those points, so that way I can make this box to figure out what the asymptotes are. Because my asymptotes are going to go through the corners of this box. This isn't part of the hyperbola, but it's a very useful tool so that I can see what the hyperbola looks like. Because now that I have the asymptotes, my hyperbola I know is going to hug those asymptotes and go through the vertex and back up. This is the graph of the hyperbola. A couple more things that we should probably write down. The equations of the asymptotes. Well, it helps a lot to use point-slope form, seeing as we have a point, and it's not so hard to find the slope. The point is the center at 3 comma negative 2, and the slope, it's going up 3 over 5, which you should recognize being the y radius is 3 and the x radius is 5. So I will write this out as y plus 2, and by the way, you can see that right here, equals the slope. This one goes up 3 over 5, so 3/5, but there's also one that goes down 3 over 5, so I can do negative 3/5 as well, times x minus 3, which you should recognize as the x coordinate of the center. The last thing that we might want to write out is the focus, or the foci. For this, it's just straight up Pythagorean theorem. For the ellipse, we had to subtract, since we wanted something inside of the ellipse. Now we want something on the outside, so we will say a squared plus b squared equals the distance to the focus. A squared is 9, b squared is 25. That's the focus squared, so 34 equals p squared, where p equals plus or minus the square root of 34, which is almost 6. So I will go up almost 6, 3, 4, 5, 6, a little bit less, down almost 6, 3, 4, 5, 6, and a little bit less. And there are the foci. If I want to write them out, I can say they're at, well, over 3, down 2, plus or minus the square root of 34. And we have graphed a wonderful hyperbola. Hope you found this helpful. Definitely check the other videos.